Hey you guys, what's going on? Welcome back to the third installment of the building a full application in C++, primarily networking. The application is called Remote Desk. If you haven't watched the first two videos, I recommend giving them a watch as you'll see me screw up a lot in the beginning. In the last video, I said I was going to go over Win32 Windows stuff. But actually, what I think I'm going to do in this video is I'm going to refactor the networking code so later on I don't have to do it because I've come up with a couple of ideas to make things a little easier for us. For instance, one thing that we're going to do is this utility class unique resource. This is completely fine, but in the TCP socket class, I'm going to get rid of all the no-throw stuff since I'm completely fine with my application throwing exceptions. I know I keep going back and forth on this, but I'm really doing this to show you guys that there are options available to you if you don't want to throw exceptions. So what I'm going to do to start with is I'm going to get rid of the no-except constructor in TCP socket. And that leaves me with a TCP socket being created. Again, if you haven't watched the last two videos, for this application, we only need TCP, and we're only going to be using IPv4. So it just makes things a lot simpler for us to use. Now, the second thing is, the only one that I want to not throw an exception is shutdown. But except should throw an exception, and this except here I'm going to get rid of. That also gets rid of the need to have this secondary constructor. Well, no, that right there is completely fine. Now we don't need the is valid checks. These are going to be completely fine as well. And receive, send, I need to find a way to wrap those. And this also. So get sock name will return socket error and get peer socket address. So the other thing I want to do is I want to create an endpoint class. And since the endpoints are only going to be IPv4 and they're going to be based off TCP addresses, the endpoint class is going to be a very simple object that just wraps a sock address in. So it's no less efficient than this, but it's going to allow us to more easily set the data. So let's get right into this. So the first thing I'm going to do is I'm going to create a module. I keep wanting to use classes, but I said I would use modules for this. Remote desk dot endpoint. And remember, we're using a precompiled header. So remote desk dot endpoint, and I want to put this in a namespace of remote desk. Now, an endpoint is simply going to be, under the hood, a sock address in structure. Okay, and we'll just simply zero the memory. So now we'll default construct an endpoint like this. Yeah, I think I'm going to mark it as default, and I'm going to set a couple of parameters. The family, AFINet. Just like this. And the default address is any, and then the only thing needed to set would be a port. So this is, everything else is zeroed out, but the family is AFINet. That means it's IPv4. So what I can do here, inline explicit endpoint, I can take a actual address. So I'm going to do, I think I'm going to do two constructors. One that takes a sequence of bytes. My application doesn't need that, so I don't think I will do that. I think what I'll do instead, uint32, or it may be like a u-long address and a u-short port. These can be no except. Well, unless the port is 0. If the port is 0, then it's actually invalid. So the family, AFINet, address, dot s. We need to get the union. Then we need to get the actual address. And we'll set that equal to h_l of address. I'm going to kind of move these out a little bit so that way it's clear that I'm actually initializing this. And now we have this. All right, we need one more thing. The actual port, h_tons, and we'll give that the port. I hate how it fixes that because I don't want that fixed. I want it just like that. Okay. What's wrong here? Out of order. Oh, I know what's going on. Port's got to be here because it's the second struct, remember? Okay. So now we have a way, but only one thing needs to be checked. If port is 0, that's an invalid port number. So if port equals u short 0, throw invalid argument, port cannot be 0. I'm pretty sure a 0 port, and we can do a simple Bing check here just to make sure. A networking port of 0. Port 0 networking. What is TCP port 0? Unlike most ports, port 0 is a reserved port for TCP IP networking, meaning that it should not be used in TCP or UDP messages. Network ports in TCP and UDP range from number 0 up to 65,535. Is a wildcard port that tells the system to find a suitable port number. Huh. Well, hold on now. So I guess I can. My bad. I lied to you. Okay, so yeah, port 0. Like, apparently that's completely fine. So that's how that works. And then what we need after that is we want to be able to get our sock address _n, get native address, and we'll just simply return a reference. Why is it doing that? Oh yeah, that's right. It's like a Visual Studio or IntelliSense like freaking out. Okay, anyway. That's good. So now we can get the native address. And the last thing that we need is, and actually I think I'm going to rename this to get socket address. I want to create a couple of static functions. I'm going to put static first. Create any with a uShort port. And of course, constants to go there. It's a static, and then static inline endpoint. Create loopback. And pass in the port. Because remember, this actually, the constructor actually handles this for us. So do we want to be able to actually get the port? I'm going to say yes. So uShort get port. It's going to be network to host short, and we're going to simply return m native address port. And that's how we get that. And here, network to host long, m native address dot sign address, and get the actual long value of the union. And the last thing, well, do we want to be able to change the port? That's the real question. I think we should be able to. Oh, and of course, I'm gonna call this get address port and set address port like this. Because get port is like a macro. I hate when it does that. And you can't directly import things to avoid that either, because you need things like AFINet and that kind of stuff, unless you're going to look up the values every time, and I just don't feel like doing that. So this is fine for our application. And here, m native address dot port equals htons port. And then to be able to set the address, set address long address. And that's going to set the address in our address space. And in getting it, we just need to cast it back to the host type. Okay, so that is our native address, but maybe we want to do something else. So let's see. Let's do a const sock address, or no, I don't want to be able to cast it. You can reinterpret this entire thing. So this is our endpoint here, and I don't think we need anything else specifically. Maybe I'm going to include, I don't see why not, address family, get address family, but it's simply going to be, and instead of inline, we can const expert this. No. Well, yeah, I'm going to const expert this. And we'll return AFINet. And so that solves that problem. And we can do one better. Instead of inlining everything, we can const expert like this. Because this is a pod or a plain old data type. So everything in here can actually just be const expert. And I'm also going to move these functions down here. And because everything is now const expert, we can actually return m native address family like that. And just change all the inlines to const expert. Which there's a cool little trick. So we can hold down Shift and Alt and we can select everything, or you can do Control and Alt and you can select only the stuff that you need to select and then change that from inline to const expert. Okay, and I think that'll do it. We don't care about destruction. We don't care about copies or moves in this case. It's a single struct. It's like 16 bytes. It's perfectly fine for copying. And moving's not going to save us anything either, so. We have a way now to create an any and create a loopback. So what we're going to do here is we're actually going to get rid of socket address. So we're just going to delete that, and inside of our networking, instead of socket address, we'll include endpoint like this. And so that will be what we need. So we can come back to TCP socket. I'm going to import remote desk in, well, I can spell, endpoint. And right now, I'm going to call this endpoint like this. Oh, there's one more thing we can do in endpoint. We can actually create a toString method. So we can't const expert this, unfortunately, but we can do std string toString, and we can const it. And I think we went over this last video, but because format is now available, we have format already. We can come back to our endpoint and we can return std format, and then we can get m native address, get the address, go into the unions, get the bytes, and we'll get byte 1, and simply copy and paste that line until you get 4. And then here we'll simply do 0.1.2.3. So there's that function, and then we can get a W string in case we need it to W string. And here we can just return std format exactly as it is here, except this time put an L, and now it's a W string. So these are just two helper functions to get strings, but we can also inline these. So instead of just making them const expert, we can inline. So these are like utility functions for us. And that looks like that'll do it. So now we need to actually get this endpoint to work with the rest of our API. So in TCP socket, we have this endpoint here. Now we're gonna call this get local endpoint. And endpoint, for some reason, looks like it's having problems. Go to the top. Why is that an issue? Is this just IntelliSense being weird? I'm gonna say it is for now. And I'm gonna get rid of the no accept qualifiers on the socket too. So we can create an endpoint like this. We can zero it out, and then we can call if get sock name Now, I am curious, though, how would we get access to this internal data? I'm guessing what we're going to have to do is just do a straight up copy. The copy shouldn't cost that much, so I'll do that. So explicit endpoint and then if m native address dot family does not equal AFINET, throw invalid argument, endpoint must be IPv4. And I'm gonna start doing proper sentences for my exceptions too. So this is the only one that's gonna throw an exception, so because everything else there's no way to invalidly set it, but this one there is. So now that we have this, Let's go back to TCP socket and try to figure out why that's not working. Let's create a socket address underscore n socket address. If get sock name int name length equals size of socket address. Now we're going to do a reinterpret cast to a sock address pointer and address of name length. If this equals socket error, and actually I think I do want to create like a helper function. So if I do like a I'm probably, I don't know exactly how I'm going to do this yet. So here when we're creating the endpoint, of course we're getting a socket error, but I want to make it easier to throw an exception of my type. So I think I am going to add a new module. You're going to see me add a lot more stuff today too for the networking. And I apologize. I know last video I said I was almost, we were pretty much done with it. We'll have to come back to it later. But I'm going to refactor most of this now because if I don't, it's going to be harder to refactor later. And if this part of the API is done, then the networking stuff will need very little change to work and be interoperable with the later parts of the application. So this is just kind of what I have to do. Networking utility. Okay, and so here all I want to do at the moment, the only type of utility I need is to basically throw if socket error, right? So I'm just going to create that function, throw if socket error. We'll make it inline. We'll throw a system error. We'll pass in the result. Oh, my bad. No, WSA get last error and std system category. Okay, so this is our function, throw if socket error. Okay, so now we can come back to, no, not endpoint. We're going to go back to TCP socket and we're going to import that. So import remote desk .networking.utility. And this is the only ones that we need, like when we're creating a socket, we may need to throw an exception specifically like this because there's no way for us to do it. Not cleanly anyway. So let's see here. Inline void close, no except, that's perfectly fine. I don't know why endpoint is doing that. It just doesn't make sense to me. It may be because it's Const Expert. For some reason, it's having problems with Const Expert. I'm pretty sure that's what's going on here. But it's completely fine. We'll ignore it for now. So now we can just do throw a socket error, and then we can wrap the call into this. And then if everything is fine, we can simply return an endpoint. I don't know why this is having such a hard time. Maybe I didn't spell the namespace right? Remote desk. No, I don't know what is going on. Because that one's fine. Remote desk.endpoint. I may just have to rebuild, but that's fine for now. Okay, so we'll throw endpoint of socket address like that. Okay, and now whenever we'll throw on socket error, we can separate this now, and we can call get sock name msocket.get. Reinterpret cast to its socket address pointer. Get the address of socket address and address of name length. And we'll throw it this as a socket error, otherwise we'll return the endpoint and we give it the socket address. So this is exactly what we need. And this, we're actually going to call get remote endpoint. I'm following Boost here. And this is just because it does make things a lot simpler for us to understand. So we're going to call this one socket address, make the variable names a little more clear. We'll actually construct it instead of emptying it out. Okay, and then we'll call throw if socket error. And simply return endpoint socket address. I don't know why endpoint's doing that, but we'll compile and test this in just a moment to make sure everything works. So there's our endpoint, and we are going to be throwing exceptions. Close is the only one that doesn't throw an exception, so that's all good. Okay, so now we're going to start from the top and work our way down. So the constructor throws an exception like it's supposed to if it fails to create the socket. I actually want these to all throw exceptions too. I know I already had the code done to do that, but we have to rewrite them, unfortunately. And the reason why is because I want to be able to just put, like, for instance, if I have my acceptor, I want to be able to create a TCP socket and just be able to go bind to this endpoint, listen. And if an exception gets thrown, I can just rethrow it, right? So it actually, first off, it's branchless computing, because if you are throwing exceptions and no exception happens, guess what? There's no branch. There's no check to see if it was binded or not. So I'm gonna do that. So again, this accept function, perfectly fine. Let's see now. Shutdown. Okay, so how exactly do we do shutdown? I could make shutdown return an exception, and inside of the destructor, I could just try catch it. Which I may, you know what? I may do that because it's going to make the code a lot cleaner. Or you know what? Nope, I'm going to keep it just like this. Shutdown's not going to throw an exception because it may be one of those things that you don't care about. I don't know. I think I'm just going to make the whole API throw an exception. It is what it is. It's perfectly fine. Wait, how did I just do that? I just learned something. Control D. Huh. Okay, didn't know that. So now we have void shutdown. And here, I'm just going to, I could actually wrap this in a throw if socket error. And just like that, we're done. And then inside of the destructor, I just simply do a try like this. And then I can do a catch. and an unreferenced parameter EX. Because destructors should never throw exceptions. Okay, so I think that's it. So now that we have our destructor called, we should be completely good now. Yep, so I'm going to go with that. That looks perfect to me. Except looks good. Bind, again, we don't want a bool. We want to throw an exception if something bad happens. So we can throw if socket error. Now the only thing that's going to happen here is I'm actually going to change this from socket address in to an endpoint. And here, so we're going to come back to endpoint and we're going to add a .get function that most people will never have to use. Static functions. So I'm thinking what we're going to do is if we come down here to the bottom right before we're doing strings, I'm going to create, I don't think Const Expert will work. And here we'll just return m native address. Oh, constant. Okay, so now we have a get function. So we just simply call endpoint.get and size of socket address in. So that's it. That is our now new bind function. So listen is going to be virtually the same. Backlog, I want to get rid of this and say int max. Nah, I think I'm just going to default it to 1. And if you need more than one client, you can do that. So throw if socket error. Okay, so there's the listen function. It's not now you're seeing how this is, it's being explicit on what's happening. Okay, and it's getting everything pretty much done for us. So this, I'm also going to call endpoint. Okay, and here we're not going to return anything. Instead, we're going to do throw if socket error. Okay, so now that's done. Okay, so now send, only if there is an error do we want it to throw something. So flags, we'll leave that alone. And we have our buffer, which pretty much is just anything. Although I think I am going to wrap this up inside of some other buffer type and have it pass that in, because then that buffer type can actually control how the data is stored, kind of like Boost. And then we can take in like arrays of chars and arrays of bytes, so different things. And this way the user doesn't have to worry about casting anything specifically. So I think I'm going to create a buffer, a network buffer is what I'm going to call it. and we'll const and not constant, I guess. So module remote-des.network a TCP buffer. Create a char array. And actually, I want to make this a non-owning buffer type. So size is going to be 0. The buffer is going to be a null pointer. So one or the other has to be true for it to be empty, and this is the same thing. If the buffer is not null, and there's valid size. And that will allow us to write to it. So we can get the size. Now it's time for us really to work on constructors. And we can, by the way, copy this around, move it. There's not going to be any overhead to this at all. So the first thing that we want is we want to be able to take in a, let's say, a vector of char. So I do not want you to be able to pass in like a pointer and a size. What I want to do is I want to be able to either take in something like a vector. So I think I'm going to do std vector of char. I don't exactly know how I'm going to do the different types here, but I think I want to eventually make constructors for everything. But for now, I'm only going to do a standard byte. And I'll call this memory. And starting with C++20, data is now non-const for certain types. So that means strings now get this working exactly as we need it to. So now we can pass in a string, a vector of bytes, but now we also want one for an array. And then we'll get the size. Now the cool thing about the buffer is it's no except and everything, so this should not throw exceptions, even if the data is empty. That is for now. Okay, and now you also may be wondering, why are these not const parameters? It looks like that we're manipulating the data. Well, the reason why is because we need to make sure it's not an R value. We need to make sure that you're not creating like an initializer list from the get-go, that you actually give me a vector. The other thing, or a vector or a string or an array of bytes. Now, the other thing that we want to be able to do is we want to be able to take in a span. So this is new in C++20, but it's a really cool type of container that basically is exactly what I have right here. So now that we have this buffer, we can take the span of std byte and we'll call this span. I also want to make sure I'm initializing this correctly. I also want to call this memory, like I did the other parameters. So it's kind of specific that I'm actually borrowing your memory, but I'm not owning anything. So span of bytes, you're not allowed to create a temporary span as far as I'm aware of. So this right here works. Now the other thing I could do is I could copy all of these and I could make more constructors for types of char. What is that? Char 8 underscore T or something. So let's go ahead. I'm going to go ahead and do 2 more sets. So this is actually not going to be a byte, but instead a char. A vector of char. And a vector of, what is int 8 underscore T? To a span of char. And then this reinterpret cast is still there just because, but I can actually get rid of that. And now we don't have to do any sort of cast, just to clean up a little bit. Okay, so that is char. So char, byte, and then uint 8 underscore T. These are the ones that I really want to do. I also want to create one for a UTF-8 string. So now, instead of byte, we'll do uint 8 underscore T. Because all these are their size is 1, so this is completely fine. And now I'm going to copy this, move this down, and I'm going to do u8 string. And this goes away on the regular string one, but it stayed on the u8 string. Okay, and I know this looks complicated because there's a lot of constructors, but this is kind of what we want for this type of buffer. Okay, and it didn't take us that long to write it. So we'll come back to TCP socket. We'll come up to the top. we'll create a TCP buffer. And we are going to, the only thing left for us to rewrite is this um only thing left for us to rewrite is the send and receive functions. So when we send or receive, I actually want to return a size t. Now we also do not want to, what happens if there's a graceful disconnect? I do not want to throw an exception here. The only time I want to throw an exception is when there is a socket error. Okay? So I can actually return. No, yeah, I want to throw exceptions for errors. Okay, so and here, so I want to actually, do I want to stream this data? No, I think I'm just going to pass it to the native socket implementation exactly as is. So now I'm just going to do a const TCP buffer like this. Now the other thing I could do, so I have this get size method, but what if I do get length? So when I have this get, I can do an inline int get length, and this could be used for natively, but this can throw an exception. So if get length, so what we can do here is if m size is greater than std numeric limits int max too large. And we could throw a simple overflow error saying that this is going to overflow with the native API. Okay. Length is too large. So the limit on length is set to int max. Okay, so now we'll go back to TCP socket. Instead of doing this, we can do buffer.getLength. Boom. Everything's done. If there's an error, something happens, something gets thrown, then we're good to go. So now that we have the result, we can throw if socket error. Then we can return a static cast size t result, which is the number of bytes. Okay, so this function now becomes very self-fluent, and we see exactly what's happening here. We're just calling a regular send, but we have this abstraction called a TCP buffer. And so you can pass in pretty much anything, including strings, and the API knows exactly how to deal with this. And so now you have this TCP buffer, and when you call send, it sends that buffer, but if it's too long, again, this doesn't do buffered reads. This just sends whatever you give me. I try to send the entire buffer over. So if you need it buffered up, that's still the responsibility of the calling code. That's not the responsibility of the socket class. And the reason I'm doing this is because this is a lower level abstraction, and you want a higher level abstraction to handle streaming. That's what TCP stream is. That's what it will do. And I'm going to refactor it to take the TCP buffer. So now that we have this receive function, the only time it will return 0 is when receive returns 0. So I'm also going to do a TCP buffer reference buffer like this. Okay, and then I can do const int result. So we'll get the underlying socket. And now I can simply throw if socket error on the result, and if it's a graceful disconnect, it's not an error. Okay, so it's still up to the calling code to check that. In the TCP stream, I may throw an exception, but it's not an actual error. If the return value is 0, it's not an error if the web server, it's not an exception if the web server returned or shut down their portion. So that's the only reason why I'm not checking it here. Only if there's an actual error will I throw a system error. So this is the code for receive, and we can get the number of bytes, and send returns the number of bytes in size t. So everything works perfectly fine. And the same thing, TCP buffer works that exact same way. All right, so now we have these. This is still a fairly low level abstraction. I don't know why remote desk's endpoint is still being weird. Maybe because it is Const Expert. So I think what I'm going to do is I'm going to take everything. I'm going to do a find and replace. Const Expert replace with inline. Replace all. Replace 11 occurrences. Let's see if now this is. Oh, look at that. Oh, TCP socket. Oh, now it's one. Something weird with that because Const Expert shouldn't. That should not have been an error, but it is. It's perfectly fine because none of this stuff's going to be done at compile time anyway. So it was stupid of me to even Const Expert it. But yeah. So the only thing that's still weird is safe socket, and that's because it's a using declaration, and IntelliSense has problems with that. So now that our TCP socket is done, we'll come back to networking. We have WinSocket library. I'm going to move WinSocket library first. We have the socket. Now we have to redo the resolver, the acceptor, and the stream. So I'm thinking the TCP acceptor is going to be the easier one to do first. Const m. The other thing is, I also don't need to catch this. So here we'll just create a TCP socket. And no, excuse me. Notice how we have the socket stuff here. We have this catch. All this code now goes away. The no throw code goes away. The only thing, these go away. No throw goes away. So now we're just simply returning msocket.accept. So here we're just going to pass in, we need an endpoint, so remote input, remote desk endpoint. I don't know why it's trying to save like that. Here we'll do msocket.bind endpoint, msocket.listen backlog. And that's it. So now this constructor is done. Because we're throwing exceptions, there's also, if nothing bad happens, like if there's no exceptions thrown, then there's no ifs. There's none of that. If there's an exception thrown, that's when you pay for an if. Although technically there is one branch, but the branch is taken care of for you, and only if there's an exception is there a performance penalty. So this is completely valid and fine code. Okay, so the TCP acceptor, wipe your hands clean, it's done. It was that easy. So now we need to go to our TCP resolver, which we have these results here, right? Well, I want to actually create like an endpoint iterator where I have a single result So we have this iterator type here that we're going to be using. Okay, so now the actual code itself does not really change. The only thing that's going to change for us is this get native info goes away. And this get endpoint function is also going to go away. And instead what we're going to do is so we have these results, but we have this has endpoints function, which I'm going to get rid of because we're going to throw an exception. If it fails to resolve, I want to throw an exception because that is the way it should be done. And this, the private constructor, I don't care about that because if you want to construct this using results and for some reason you need to use it outside, then this is perfectly fine to have in our class. And so we're going to come here. We want to. Okay, actually, I don't want to throw that here. I'm going to allow you to hand me invalid results, and yeah, it's going to be messy if you're going about it the wrong way. So we'll fix all this in a minute. So now we have this, and we're actually going to do const int results. I'm going to look up the get address info function and look up winsock2. And we're going to go to the return value. Failure returns a non-zero Windows socket error code. So if it's not 0, that is the error code. So if it does not equal 0, then we have our error code. Then we can throw system error of type result. And then just to be on the safe side, if results free address info results like that. And let's be a little more specific. Say that's not a pointer. I don't think that'll ever get called, but I want to make sure it doesn't. So that, and I really don't know why I keep using parentheses to construct objects when I should use the curly brackets, but okay, this code right here is perfectly fine. And then we'll return the results if we have any. Okay, so that is the get add. This is a resolve function if it fails to resolve anything. So if result does not equal 0 or result, well, no, because it should fail if result's not 0. Okay. Now we need to get an iterator. And the only thing I need now is I just need the end. And the actual address info is going to be the beginning. So now, because this is a list, there's no way to actively get a size. My bad. This should be address info like this. And here, we'll get the endpoint. So we'll do a get endpoint, and it should not throw an exception. So now the only thing here is if address is null pointer, we'll throw invalid argument. Well, okay, so null pointer may actually, well, no, because you just don't need read access. So we're going to allow one passed, but now this is reading it. So I'm thinking if it is null pointer, that is completely fine. It's only an error if you tried to get the endpoint. I don't know. How exactly do I do this? Because I want to make this, a C++ style. So iterator, begin. I'll return an iterator. And this right here is going to be explicit. Oh, the iterator also needs an end. So if address does not equal end, yeah, see, I'm not exactly sure it's a responsibility of the iterator to be able to go to the next one. Maybe it is. I don't know. Okay, maybe instead of storing the end here, we actually do return an iterator. And whenever we do plus plus, what's going to happen is we're actually going to return a new iterator maybe. So, and we don't need to look for the end. We're just going to have a bool is end. Inline explicit operator bool. This will check if it's not null pointer. I actually don't want any of this. Instead, I have this isEnd function here. So again, this is copying the data. So void operator plus plus. Yeah, this is hard because this is like a linked list. But all I know is I need to set it to AI next. And this is only if it's a valid address. So let's see, is the end. It returns this as null pointer. Yeah, because this iterator is read only. You're not going to be able to write to it, so this is completely fine. And we just have the get endpoint. I'm really doing too much here because we really don't care about this. I care about the first result. But what if you care about more than that? See, yeah, this application, I'm really about to sit here and write iterators and all this. I don't need any of that. All I need is I have this result class that's here. I'm gonna change this to result, and then I'm going to have one. So you have address info results. The API pretty much is going to be exactly the same, except it's going to be called result, and you're going to be able to get an endpoint from that result. Because then it makes it specifically clear that this is a single result instead of multiple, which is perfectly fine for my implementation. And then we can just do endpoint get endpoint. And we only throw an exception if it's null pointer. So if m address info, well, socket address, and then we can I'm really thinking that because we're specifying this, if we do the address length, if it does not equal size of socket address underscore n, or m address info family does not equal AF inet, which would be, IPv4. Then we can throw result is not a valid endpoint. Something like that. And then we can simply return an endpoint. Now we're gonna do some funky trick stuff here, but this is perfectly fine for my code because I know that this will work perfectly fine. So we need a sock address in, right? So sock address underscore end pointer. And we can make this const. And we can pass in our address info address. And then we just simply dereference. And that's how we get exactly what we need. And that right there should create the endpoint. And that looks good. So now you just have this get endpoint function, which can throw an exception, but it's completely fine. And then I'm just going to sit here and say if results just equals null pointer, row invalid argument, results is null pointer. Okay, so now we get this and we can pass in our results. Oh, a single result. There we go. All right, so TCP resolver is now done. It just has a single function called get endpoint. All right, now it's time to fix our TCP stream. Okay, so of course TCP stream If there is no socket, which cannot be possible now, because if a socket does not create, then this code does not work. So we still have our buffer size. I'm also going to make that C buffer size. We want no copy. We're going to default moves. We have basically a default destructor. We have this get socket function. And we are going to do send. Okay, so send, I'm actually going to get rid of all of this. And we're going to include the buffer, input remote desk TCP buffer. Inline size inline void send. And all this is going to do is it's going to send all of the data. So const TCP buffer. Okay, so now notice now we're only creating one function, and TCP buffer takes care of creating everything that we need. So now that we have this buffer, we're going to create an int pointer, and we're going to call this num bytes sent, and we'll initialize that to 0. While num bytes sent does not equal buffer.getSize, and here we can static cast this to size t. All we need to do now is we need to, okay, so we're just going to do the same thing that we did before. So const auto iterator current position is going to equal buffer get plus. Now I also want to be able to, I guess, get the end of the buffer. Okay, so that is the current position, which turns out it's a const char pointer. Const auto distance to end. And this is going to be, we need to basically get our current position. And we're going to use the current position, and we are going to go from current, and we need to get the distance to the end. Like that. So that gets us the end. That now we have the distance from our current position to the end. Const size t. And we have result here, and we're going to do msocket.send. Now, what we need to do is we need to create a new TCP buffer. So the only way I know how to accurately do this is we want to add one more line of functionality here. And this is going to be able to pass in a void pointer, which is something that you shouldn't do, but is completely valid. Oh, well, we do have the one for span, and we have span of char. Yeah, let's do that. Let's do that. This way the code stays a little bit cleaner. Yeah, I think I'm going to do that. So we're going to send. We'll go ahead and close that off. And then we can do num byte sent plus equals static cast std int pointer t result. Like that. Okay? So what we need is we need a TCP buffer. But how does this TCP buffer actually work? So what I'm going to do here is I'm going to create a couple lines of code. Current send buffer. And we'll just send current send buffer like this. And of course, flags are 0 for this abstraction. So now the current send buffer. Now again, this is more code, but the code is more readable. We realize that we're creating a buffer, and now we can pass in a span of char. Okay, and now what we can do is we can actually pass in our current position, and now we can do a so I'm thinking we're gonna do this like a function call. Okay, so this way it's a little more clear what's going on. Static cast size t. And all we need to do here is we need to give it a valid size. Let's just say I did 1, right? Well, something else is going on. Argument types of const char pointer. Oh, I see what's going on. Close the resolver. Okay, so spans, they can either be const. So, okay, so what I need to do is for each span, I need to, we'll see, but that doesn't work because then the API gets destroyed. I'm gonna allow overriding. I don't really know how else to get around this. Because now this works if I do this, because the problem is current position is a char pointer, right? But if it's a const char pointer, then this needs to be const char, and if it's const char, then it won't be sent correctly. So they'll create a span of char. I wish there was const on the constructors because that would make this a lot simpler. Which may be why Boost. This is fine for my application, but I think this is why Boost has like the const buffer and the immutable buffer, because then the actual constructors are different. But this works. So now we can get our size t, and we can do our distance is a pointer difference. So that's good. So what we can do here is we can actually do std min, whichever one is less, c buffer size, or distance to end. And we'll get whichever one is less, just like we did before. And now we'll send that current send buffer, and number of bytes sent plus equals result. And this right here gets our, this is our send function. And if an exception gets thrown, then it has to be handled. So another thing that could happen here is we could write this entire thing in a try catch block. In debug mode, it's not, debug mode will stop, but you can have a higher level try. And so you can just try wrap around this and it will work just fine in release builds. So I'm going to stick with this, and now receive, right? receive is going to be almost the exact same function, except this time it's not a const buffer. It is just a regular buffer. And in this case, we can receive current send buffer. And I'm gonna rename this to current receive buffer, like this. And I know this looks weird, but we are receiving, and we're basically just passing in that receive buffer there. So num bytes received. I think it is important that we have good naming. So someone else comes back and looks at this code, they know what's going on. Like you hopefully know what's going on. Okay? We're just basically, while this is true, so while the number of bytes that we have received is less than the buffer size, then we'll get our current position in the buffer. We'll get the distance to the end. We're creating a current buffer from the current position, and we're specifying a size of either the buffer size that we want to dispatch or the distance to the end, whichever one happens to be the minimum or smaller. Then we're getting a result, we're receiving, and then we're adding the number of bytes received from the result. Now, if result equals size t0, then we will throw and gracefully closed. So only in the stream does an exception get thrown. Okay? But like for instance, if you just want to send over something, you can use the socket send function, but this is going to be way better. But now that we have a send and receive function using buffers, now we can implement our own type. So we have this stream, and what we want here is we actually want a we want like a packet. So we're going to create a TCP stream packet. And we want an enum class packet type. And we'll just make this a uint32t. Okay, and now that we have a packet type, I know too that I'm going to need is screen, mouse event, keyboard. I'm gonna like, yeah, and then we'll create custom packets to actually deal with this. So keyboard event. So like when, like, okay, because again, this is going to be, it's kind of hard to explain this at the moment because we don't have any of the other application up. So I think what I'll do for now is I'm going to leave the packet part out and we'll add that later. Now that the rest of the abstraction is done, I think that's going to make this a lot easier. Now we need to go back to networking, make sure endpoint is in there, TCP stream. Okay. Now we're going to go back to our WinMain. Now we're still importing networking. We have our WinSock library, remote desk, TCP socket. We'll create a socket like this. Remote desk, TCP resolver. And we'll do the same thing that we did last time, which again, the resolver, I'm going to actually get rid of the static. I'm not going to get rid of the static function because that makes it way easier for me to use. Oh, you know what? You know what? Watch this. I'm going to do something really cool. So I'm going to keep this as like an object that does not have a static. So we'll get rid of static, right? But then I'll create a export class DNS, and then I'll have a static TCP resolver result resolve, a string for host, and a string for the service. And here I will create a TCP resolver, and I will return resolver.resolve host service. So now you can do DNS resolve, and it makes a little more sense. So this is just I don't know, a static helper class. So this way you have to create a resolver, but I like the static functionality, but the static functionality should be separate in my opinion. So that's why I did this. So now that I have a socket, I can do socket.connect. And what I want to do, now we need an endpoint, right? So now we can connect to let's connect to Google. So we can do DNS. So remote desk DNS resolve google.com on port 80, like we did last time. And simply call .get endpoint. Look at that. It's a single line of code. We're able to, it's very clear what's happening. We're going into the remote desk namespace. We're accessing something called DNS, and we're resolving. Well, we know DNS means domain name service, so we're resolving google.com on port 80, and we're getting that endpoint to connect for the socket. So this single line of code, even though it may be long, is very clear what's happening. So now that we've connected, we can now create a string, and I'm going to call it this, the request. And I'm going to create another string and call this the response. So now we have our request, and we want to simply, let's see, get /http 0.0 carriage return line feed host google.com carriage return line feed user agent. I messed that up last time. I'm just going to say remote desk version 1.0 carriage return line feed. There's our request. We have our response. I don't know why I camel case these. Response.resize. And I'm just going to resize this to 1024 times 1024 times 2 megabytes. Okay, and now I'm going to do request. Socket.send, and I can send the request because guess why? Because it's a string, right? It's implicitly convertible to a TCP buffer. So the implicit conversions I actually want here. But maybe I don't want them, but for now, I think it's fine. So you can just send the request like this. And if you want to be correct, you could do like a TCP buffer of type request. And of course, it's remote desk TCP buffer request. Okay, so now that I sent that, socket.receive, and we will receive remote desk TCP buffer response. Why is it having problems doing that? Initial value of reference to non-const must be an L value. It is an L value. What? I see. Oh, you know what? I am an idiot. Let's go back to TCP stream real quick. These don't need to be references. These can be copies because it's simply a pointer and a size. Look at that. I got rid of my own problem. And now if we go back to TCP Buffer, watch this. You ready? You ready? Go back to TCP stream. Ta-da! Problem solved. We don't get that weird error anymore. And yeah, we don't get that weird error at all anymore. That's cool. Okay, and now we can go back to our TCP socket. We can change the send and receive functions in this as well. So we have receive. That's just a buffer. That's just a buffer. And const there is perfectly fine, but we don't need it. Okay. Now we can go back to win main. See, that's why we have to write some sort of test. So now we're receiving the response. Text.txt. And then we'll call this file. Same thing we did last time. File.write. We'll write the response.cstring response size. Now let's see what happens when we run this. It should, without a problem, connect to Google. It should send that request and we should get a response. I have to look at some of those warnings coming up. Uh-oh. Well, let's see whenever it fails, because maybe something's there. But this is why we need to test. So it connected without a problem. It did not send the data. So something happened with send. Networking's good. Let's go to TCP socket. Receive. Send TCP buffer. I don't know why it's failing, but let's just see. So connect is working perfectly fine. It's not until we get down here and we're sending it. We're sending the request, just making sure. And then there is an error, but I don't know why there is an error. Let's go back to socket. See, it should. Whoa, 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 whoa. What just happened? I hit continue and it sent? Huh? That's weird. Okay, anyway. Let's receive. Exited with code 0. What is going on? Let's see if it got the page. Let's see if it got the. There's file. There's text. It says blank. But it receives. Oh, because it didn't receive something. What is going on? Throw is socket error. You know what I think I'm going to do? Just so I can get the actual message. I think what I'm going to do is go back to web main and just wrap it. This is another good thing about using system error. So I'll do a try here, because I don't care about the rest of it. All right, and now we'll just pop up a message box if something bad happens. So let's see what happens now. The system detected an invalid pointer address and attempting to use a pointer argument in a call. Let's go to the error list. Resolve function assume not to throw an exception but does. So there's one thing. Result function. If results is null pointer, throw invalid argument. Wait, oh. Get length, not all control paths return a value. That's what's happening. Now no exception was thrown. Now we have it. I know it's a bad result just because I don't remember offhand everything that's needed, but now we're getting data. So that was the problem, this get length function here, and there was some no except stuff. So now if we go to error list, there's 0 warnings, 0 errors, which is exactly what we want. Now, there is one more thing I think that I want to do, and that is I want to everything else looks like it's going to work just fine. So I need to test now the TCP stream. So if I will go back to WinMain, I have my socket. I can pass my socket into the stream. Oh, there we go. So I can send and receive, but maybe on the stream end, I want to be able to bind and listen and stuff. No, let's do that on the socket. The stream should just be used to receive and send data. So now we're connecting. Now we have this response.resize. So now what we can do is we can use the stream.send the request, stream.receive the response. And of course, this is going to throw an exception, so the file should never get written to, and the exception should be the connection was gracefully disconnected. Uh-oh. Yep, I'm stuck in a loop somewhere. Because I can see my CPU cycles going crazy. So we'll go back to TCP stream. We'll go to send. Well, let's see which one it's actually getting stuck on first. So we get send and then receive. So it's stuck on send. So we'll go to TCP stream. So now we'll go into the send function. So there's that. Why does it have such a hard time? This breakpoint will not currently be hit. No executable code of the debugger's target code type is associated with this line. Yes, it is. Would you please get in there? Okay, let's review the code manually, and then we'll figure out what's happening. Okay, so we have the number of bytes sent, which is 0. While the number of bytes sent does not equal the buffer size, we get the current position, which is buffer.get plus buffer. There it is. There's my bug. Num bytes sent. And then I need to make sure I do the same thing here. Okay, now when I run it, something else should happen. So send should be no problem. Receive should be no problem. The connection has been gracefully closed. And that is my stream. The stream is now completely done. Okay, and now what we can do is, now that we have this request and the response, we can put these up here, right? Oh, and then we only need to resize it right before. So we'll connect, we'll send, we'll resize the response, we'll receive it, and then we'll write whatever the response was to the text file, which may be nothing. The connection has been gracefully closed. And if we go back to our text file, it's 23. All right, let's run it again and see if the seconds changed. Just remember, it's 1531. So there's 1531, and that is 1549. So it is changing. Everything's good. Yeah, so there is my stream. Now it's time for our TCP acceptor. So we need to do another client application. And so the way that we're going to do this is, again, we're going to use a thread. We'll create the client. Like this. And here we will create a remote desk TCP socket, which will be the actual socket. And then socket.connect, we will connect on the endpoint. So remote desk endpoint, create loopback, and we want to do loopback of 2302. Why not? So there's our endpoints. See, just like that, single line of code, we have an endpoint. It's clear as day what's happening too. Now we can do socket.send. And watch this. I may want to be able to send stuff like that to make the API a little easier to use. So we're going to add the ability to send those types as well. So inline TCP buffer const pointer string. Oh, and look at that. It is already a size T, so that works out really good for us. Const char cannot be used to type char pointer. Actually, see, I don't know. I don't like that. Let's see. Does this work? That's the first thing. It does work, but it's not going to be able to change it. So yeah, I don't know about this one, folks. I'm not going to allow that. Yeah, because then you can write to the memory. You shouldn't be able to write to it. So I'm going to not do that. Okay. So we're going to have a so we need something outside of the scope of the send. Simple hello world. We'll send over the message. Yeah, this is still not a lot of code, and it actually makes more sense because now you know what you're sending. And now I'm going to create a remote desk acceptor. And actually, what I wanted to do with the acceptor is I just want to be able to pass in a port. So you can give me a socket address, but I also want to be able to just take in a port number. I mean, maybe you do need an acceptor, but the port number one. Like this, we'll create the socket, and then what we'll do is we can actually call TCP acceptor. We can actually just forward this over there, and then we can create an endpoint, create any from this port. Okay, and now it knows that we are calling a constructor. So that is that, and then we can pass in the backlog. Okay, so we just forward this to this constructor, and that works perfectly fine. So now I have my backlog. I think I'm going to default these to 1 as well, so they're not needed. And now we come back to win main. Boom, I created an acceptor on port 2302. Think that, I mean, that was pretty easy. Or you can do endpoint, remote desk, endpoint, create any, 2302. That is exactly the same as just passing in 2302. So it does make it a little easier. So now that we have an acceptor, we can do auto client equals acceptor dot accept. So now we have this, and now we can do a string message dot resize to like 30, something stupid, and then we can we'll do client dot receive. So what we will receive is the message, and then message box A 0 message dot C string 0. Okay, so let's see. We should get our hello world from the client, and we do. And so now we can change this to anything, and we'll just say hi there. And as long as it's 30 characters or less, we're going to get it. So that is the TCP acceptor, TCP stream, TCP socket. The last thing I want is, now that we have a client, I want to do message box A 0. I'm going to do client dot get remote endpoint dot to string dot C string and 0. And so I'm going to do my toString method there, 127.0.0.1, and there you go. Now you know this is a local address. So that's cool. So now what if we wanted to construct an endpoint from a string? Because that may be something else, like when the user is inputting an IPv4 address, we may want to be able to do like a from chars, but turns out there's an even easier method than that, and we're not going to do it here, but there's I think it's inet pton. So if we look up winsock2 inet pton. Pointer to network. Use inet pton. inet pton w. Function converts an IPv4 or IPv6 internet network address in its standard text presentation form into its numeric binary form. The ANSI version of this function is inet pton. So we have a family, we have this, and we have our address buffer. So if we pass in AFINet, a pointer to which, when the family is this, it should be large enough to hold an in address structure. But there is actually an even better way, and I could show you that here. So, if we have a direct IP address, instead of doing it from string, so like instead of doing create loopback here, we can do remote desk DNS resolve 2302. So now we can just pass in the strings directly, 127.0.0.1. And of course, .get endpoint. Okay, so now you can just resolve, and you can resolve IP addresses like this. And this should run exactly the same. Hi there. And so you can do this. This is a little slower than getting an actual IP address from string, because this is calling like some domain name service inside, like in Windows. But it's completely fine. You're using networking. You're literally connecting over a network anyway, which there's a delay for. So a resolve is not gonna. It doesn't cost anything to do a resolve in this context. Like just don't do this in a real time loop, and you'll be fine. So that is how you will get like a string go from a string to this. Now we could do endpoint from string, and we could do that, but this is already done for us, and it's already done really well. So I'm gonna leave that alone. I think now we are done, because now we also have network utility, which has this throw if socket error. But we also want to come back to our WinSock library and get rid. Okay, we already have only exceptions. That's perfect. So we may also choose to do this on the free store, and you can wrap this inside of a unique pointer, and it would be just fine. Now the other cool thing though is I've discovered that since WinSock library, all libraries in Windows at least, you don't need to worry about moves. You could delete the moves and not even have to worry about checking is initialized. But in my case, I'm just going to keep the code as is, just because it makes it simple. And the TCP buffer, again, we can take standard bytes, chars, and uint 8Ts. And this is going to make our lives really easy. Oh, we could take arrays, vectors, and spans too. So if there's another data type that I come across later, I may add constructors for those. But we also have the string. So we have a string and U8 string. And so since this is going to be like an American only application, it's not American only. It's going to be English only. I'm sorry. I'm not going to worry about doing translation tables and all that kind of stuff, just because this series is already going to be like 50 to 70 videos, right? Like if I were to make this as extensive as possible, it would take forever. And if you really want to use Unicode correctly, you should download other libraries to handle that. But in my case, this is perfectly fine. So, yeah, I think we're done. We've tested client threads. We tested our endpoints. So if I were to do like get local endpoint, I'm wondering if 127.0.0.1. So that is going to be the same, but it's not going to be the same if a client in like Tunisia were to connect. The local address Local endpoint may be the same, but the remote endpoint would be whatever their IP address is. So that's how you get that. Like if someone connects to your server, you have the acceptor, you accept the client. When someone uses you, you call the get remote endpoint function, and you can just call toString, and everything works just fine. So let's see. Is there anything else specifically I need to test? And other than that, now notice that there's no ifs. There's none of that because everything just throws an exception. So again, I'm just going to connect to Google to show you how easy this is to use. You have to wrap it in try-catch blocks, but it's completely fine for what we're doing. We're just message box it out. A means ANSI, by the way, and then message box W is the wide string. That's where you would get Unicode and stuff. The correct way to do this is to use null pointer, no caption, and MBOK. This is the real way you're supposed to do it, but I'm not too worried about that right now. So remote desk, we create the WinSock library. We create a socket to connect to. And then we can do socket.connect. And then we can do remote desk DNS resolve google.com 480.get endpoint socket.send the request socket.receive the response. And yeah, so then you send the request, you receive the response, and then you do whatever you want with the response. So notice there's no ifs here. I just have what happens if something fails, okay? And this is what goes here. And now I can write my code. And if nothing fails, then there's like no overhead to this try blocks. I think that's only true on x64. Y'all are more than welcome to double check me on that and fact check me. Leave a response down in the comments. If you think anything I said is inaccurate or wrong, I'm willing to change my mind. I've done a lot of testing with networking code, and everything that I have learned is from books and just self-implementation and reading the MSDN and the Linux documentation, stuff like that. So if I'm wrong on anything, please correct me so I can get the information correct when I'm making these videos. I have no problem admitting I'm wrong, as I do 95% of the time, because I always do stuff wrong, like every programmer. So leave a response down in the comments if you think that something was messed up and you would like for me to address it in the next video. But at this point, I think we're done. And in the next video, we will either look at some of the comments that were left so we can determine whether or not something I've done is wrong or there's a better way to do things. And if not, if everyone's good to go, in the next video, I will be starting my Win32 window. I will be creating a window and starting a message loop. And we'll go over some basic stuff in Win32. And the videos after that will be DirectX 11, and then we'll go back to networking to include packets, that kind of stuff, so we can send data over the network, and then DXGI output duplication and the send input API to send input between the admin or the person operating the help desk part of the application and the client. So the server will be sending, like when they have control over the other person's computer, they will be sending events to the client, and the client will use the send input API to process these events, and then the client will use DXGI output duplication to send their screen to the server. So anyway, hope forward to seeing you guys in the next video. Y'all take care, and we will see you then. Have a good one.